As the world becomes increasingly aware of the need for sustainability and environmental protection, integrated production is becoming more important in production processes and as a building block of the circular economy. But what does integrated production actually mean? Integrated production is about efficiently utilizing byproducts. Waste gases, wastewater, and waste heat from one plant to support chemical processes in others. Integrated production at Wacker is more than just a theoretical concept. It is a living reality that maximizes material use and minimizes energy consumption. And it is helping us to realize the goal of the circular economy. Our great strength lies in our closed material loops. At our production sites around the world, we have created unique systems that keep transport routes short and conserve resources. Our integrated production system is based on two pillars: integrated energy solutions and integrated material systems. Let's take a closer look at these. Integrated energy solutions are based on the principle of repurposing waste heat. This involves capturing the heat released during chemical reactions and redirecting it to other production processes. For example, instead of consuming primary fuels, the waste heat from chemical reactions is utilized to generate steam that can be used for heating or can serve as process steam in other plants. Another example is the preheating of water used in the production of deionized water, or DI water for short. Here, the original water is too cold, and so it is heated with the waste heat captured from turbines and chillers. This saves on energy and cooling water on one hand and cools the turbines and chillers on the other. Integrated material systems, on the other hand, are about utilizing byproducts in material loops in order to conserve raw materials. More specifically, byproducts generated in one process are either processed and fed back into the production loop or used as raw materials in other processes. The various production processes mesh together like gear wheels, sustaining the flow of materials around the integrated system. One example of this is the relationship between hydrogen chloride and the silicon integrated production system. We have replaced a large proportion of energy-intensive hydrogen chloride production with hydrogen chloride recovered from downstream production. In the silicon integrated production network, silicon is converted into intermediate products that contain chlorine, from which chlorine-free end products such as silicones, hyperpure silicon, and pyrogenic silica are produced. The process also produces hydrogen chloride. In addition, waste gases containing chlorine are used to produce hydrochloric acid and steam. Another example is the acetic acid integrated production system, in which methanol, methyl acetate, acetic acid, and ethylene are recovered through various recycling loops. This allows us to save on the purchase and transport of well over 1,000 tank cars of raw materials a year, the equivalent of a train almost 20 kilometers long. And the recovered acetic acid and ethylene can be used to produce vinyl acetate monomer, or VAM for short. This is the raw material for almost all of Wacker Polymer's sales products. Wacker is a pioneer of integrated production, and together with our partners, we are driving down the generation of solid, liquid, and gaseous waste substances through our integrated approach, and in so doing, we are indirectly making substantial savings on greenhouse gases. Integrated production, therefore, is an important component of the circular economy. Through it, and by working together, we can improve tomorrow's world today.